from the 21st to the 26th September 2020 is a World Green Buildings Council's annual campaign that empowers all to deliver greener buildings, where they call on the building sectors, policymakers, and governments to take urgent action to deliver net zero buildings. They also call on them to provide a showcase for those leaders already taking action to show where, why, and how they are achieving it. It is time to bring these solutions to scale, and the industry is ready to deliver. This campaign is threefold. It's for the communities, for the planet, net zero buildings for economies. With this thought at its core, the Prem Jain Memorial Trust, in association with the Indian Green Building Council, is doing a week-long celebration, the PGMT World Green Building Week 2020, wherein each session is being presented by an eminent sustainability stalwarts and exclusively curated for our partner institution and their students. These eight sessions span from the 21st to the 26th of September. This event is a tribute to Dr. Prem Jain, fondly known as the father of the green building movement in India, and his lifelong commitment to education and sustainability. He was instrumental in single-handedly creating a green Bharat and ushered in a shift in the way buildings are conceived, designed, and built in India. He facilitated India stands tall in the global green building movement and aspired for India to be Jagat Guru in the sustainable built environment with the vision that every Indian contributes 1 square feet of green to their motherland. The Prem Jain Memorial Trust has been involved in a number of activities, and the prime focus has been green education for students, be it for holding bi-monthly lectures for students through Building series and Prem Jain Colloquium series through eminent industry speakers. Session-wide video recordings of which are available at the PGMT website for students. The Trust is also involved in supporting unsung, unrecognized, young, bright talent in schools and colleges with support and intervention initiatives. The Trust continues to promote green innovations, technologies, and celebrating achievements of technologists dedicated to promote sustainability. The PGMT extends their gratitude to the IGBC and the IGBC student chapters, Sustain and Save, and the respective institutions and faculty member. So today, hi, I'm Ankita Shroff from Sustain and Save, and I'm extremely happy to be collaborating with such a big initiative focusing on sustainability. And over to you, Payal, to take this forward. Thank you.
Thank you very much, Ankita. A lot has been said about the event and also about Dr. Jain, so I won't take too much time here. I do want to speak about Dr. Jain from a personal point of view. Prem Jain Memorial Trust was founded in his memory 2 years ago. He was my father, and the mission that he lived with was sustainability and education were two foundation stones of his life's work. So these are the two missions that we follow in the trust also. From a personal point of view and to people who did not know him, I would like to share that he lived on the path of dharma, justice, integrity, truth, and humility. Everything he did was with purpose and intention, commitment and dedication, kindness, compassion, and love. That's what made him so special to all those who were attached to him, who worked with him, who studied from him, and who associated with him. On a personal level, he was the best and the most amazing father, husband, mentor, guru, son, brother, whatever you may call it. His lifelong commitment is best expressed in the words of Gurudev Rabindranath Tagore, where the mind is without fear and the head is held high, where knowledge is free, where words come from the depths of truth, where the mind is led forward into the heaven of freedom, my father, let my country awake. When Dr. Jain took over chairmanship of Indian Green Building Council in 2007, he set his sights on achieving 1 billion square feet. India at that time was 1 billion strong, and his mantra was 1 square foot for every Indian. Soon, with the IGBC's commitment and dedicated passion, they reached 1 billion square feet in 2011, even though the target was 2012. The next target and the next milestone set was 2 billion square feet for 2015, which was also achieved by 2014. By 2018, we were at 5.7 billion square feet. And I know at last year's Green Building Congress, they hit 7 billion square feet mark. And it goes on and on and on. Dr. Jain's connection with Indian Green Building Council goes back to 2003, when Spectral and Dr. Jain got involved with designing Godrej Green Business Center, which eventually went on to become the world's greenest building in 2004. And his association with IGBC continued, and they brought 60 platinum, 40 gold awards to India, and many, many more. The journey continued. The Indian Green Building Council, part of the Confederation of Indian Industries, was formed in the year 2001 with a vision to enable a sustainable built environment for all and facilitate India to be one of the global leaders in the sustainable built environment by 2025. As you all probably know, IGBC is responsible for developing new green building rating programs, certification services, and green building training programs. They work closely with state governments, central governments, world green building councils, bilateral and multilateral agencies in promoting green building concepts. Today, I want to especially thank the IGBC partners we have with us, IGBC student chapters, Kate Group of institutions and colleges, Mr. Siddharth Jain, who has been our partner from the beginning, from the first memorial address we did in early 2019. Thank you very much for being with us. For Sandeep Narang, whose brainchild this is, and thanks to whom we are here today doing a week-long celebration. Ankita Shroff, Sustain and Save. The entire board of governors and trustees of PJMT, and the back-end team which makes each one of these sessions happen. Ashish Rakheja, who is going to be our speaker today and who is also a founder trustee of Prem Jain Memorial Trust and has been a big catalyst in bringing us this far. Thank you very much, and back to you, Ankita.
Thank you, Payal, for the kind words and telling us about what all has been done and who's been a part of this. Moving further, we move to our next speaker who will be introducing our speaker for the day.
Yeah. So good afternoon, everyone. Myself, Siddharth Jain. I am assistant professor in Department of Civil Engineering. So first of all, let me appraise you about the KITE group of institutions from which I am belongs to. So KITE group of institution was established in 1988 by Krishna Charitable Society in Ghaziabad. It is located at Ghaziabad Meerut Road. The institute offers BTech degree in various branches. Apart from that, we have a program in pharmacy, MBA and MCA. KITE is also accredited by NAAC, and various programs have been accredited by National Board of Accreditation, that is NBA. Now, the Department of the Civil Engineering was established in the session 2008 and 2009. Till now, many batches have passed out. The department is having a state-of-the-art laboratories and a greatest infrastructure at all. Now, I would like to thank PJMT for associating with us. And now I will tell you something about the speaker. So Mr. Ashish Rakheja is the managing partner of Aeon Integrated Building Design Consultant based out of India and has a postgraduate degree in thermal engineering with over 25 years of work experience. He is a seasoned consulting engineer who has designed over 2,000 projects, including hotels, airports, hospitals, residential, commercial, and many others. Mr. Rakheja specializes in high-performance building and has been actively involved in leading design activities of electromechanical and services of 3 net zero buildings and over 40 platinum-rated green projects in India. Sir has rendered his valuable services as the past president of ISHRE and ASHRE India chapter, chairman of the technical committee for green building, Indian Green Building Council, Environment Committee at PhD Chamber of Commerce, and many others. He has also been an advisor to International Fenestration Forum. He has been given a Lifetime Achievement Award by ISHRAE and ASHRAE India and has Distinguished Service Award from ASHRAE. As a devoted teacher, he has been a visiting faculty for over 15 years at 3 of the leading colleges in National Capital Region. Mr. Rakhija has contributed equally to the development of codes and standards in the country. He has been the panel member of National Building Code (NBC) of India, Energy Conservation of Building Code, Chiller AHU VRF testing, standards, member of Technical Committee at EESL Ozone Cell HPMP projects, member in panel of experts of space conditioning under FLCTD program by UNITO and BEE and many more. Sir, on behalf of Kite Group of Institutions and the Department of Civil Engineering, I extend a heartiest welcome to you and all the other dignitaries. Now, I request Sir to kindly take over the session. Please, sir.
Thank you, Siddharth. Thank you so much. And namaskar, everyone. Delighted to be here today as a speaker. I was part of the inaugural program. Some of you would have been there at that point, but I'm happy that I'm here today as a speaker on the net zero energy buildings. Now, net zero energy buildings has been my passion, and the foundation for which grew came at the time when I was associated with Dr. Jain. Incidentally, I've closely worked with him. Malik, if you can take out your slide so that I can start showing my presentation. Yeah, thank you. So I have worked with Dr. Jain for nearly 25 years, and he was a wonderful man, as Payal said, wonderful teacher. And whatever I know today, I owe it to him in terms of my knowledge, in terms of what I've been able to achieve in life. And it's so heartening to see that after him, we have carried his work forward, of course, helped by his wife, Mrs. Jain, who's also part of the audience today, and then Payal, his daughter, who's carried the message forward. So I'm grateful. Thank you, Narang Saab, for giving us this opportunity to hold this program. You collaborated, you helped us very well, and thanks to IGBC for working with us on this one. I'm just going to put some few things there on the screen. Okay. So as I said earlier, that I'm going to be talking on subject of net zero energy buildings. You had a similar session in the beginning of the program on Monday, which was on net zero energy projects. So I'm going to take that forward and I'm going to break it down in terms of what net zero energy buildings are and how do you achieve them. Before I go forward, I'm going to show you a video. This is something which is very close to me, and if those of you have heard of Carl Sagan, and he's very famous in terms of what the work he has done in astronomy, in terms of what he feels about what Earth is like, and it's one of a very famous work. The video that he had released, it was called "The Earth, a Pale Blue Dot." I'm going to run the first 3 minutes of that video to set the context of what we are going to be talking about today.
That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
All right. So, I came across this video nearly about 15 years back, and it was such humbling experience to hear what this man said and what this meant, a pale blue dot, that since then, for all my presentations that I've ever done, I've used this screen as a starting screen to remind me that where we stand in this vast universe. It is our responsibility to build in harmony with the nature, and that is where the next generation of buildings, which is the net zero buildings, comes our way. Today, whenever we construct a building, we are always worried about the environmental footprint of it. We are worried about what harm we are going to do to the nature. And this is how the building industry is associated with. Going forward, the day we are able to move to net zero construction, and which is what I'm going to define to you in a little while from now, you'll understand that we are moving towards the era that when we construct, we'll be doing something good for the planet. Each building will contribute in a positive manner, and if not positive, at least it will not harm the nature. And that's what the net zero buildings are all about. They are a new frontier in sustainability. How do we go around defining them? Imagine a building where you get no electricity bills. Today, whenever we are living in a building, there is an electricity bill which comes to us. But imagine these buildings have no requirement for electricity bills at all. These are buildings which are standalone from the electrical grid. There is no cost for running the air conditioners or for running geysers for hot water in the winters. They utilize natural resources. They live in harmony with the nature. They're built in harmony with the nature. These are the buildings which have lowest possible carbon footprint. And that's what truly what an earth-friendly building or an environment-friendly building will be all about. And that's what we'll call a net zero energy building. The concept has been around with us for a long time. If you look at the history of mankind, over years, we have lived in harmony with the nature. It's only in last few decades that our greed took over. And in that process, we started extracting more from earth than giving back to her. And that's where the disbalance came into the picture, the imbalance came into the picture, and we have to now today start worrying about harmonizing with the nature. Man has always in past respected and worked around the nature. And that's what we need to go to achieve the status of net zero buildings. The net zero buildings are broadly categorized into four. The first is net zero energy buildings. These are buildings where we are neutral with respect to the electricity grid, the grid which provides us the power which comes from the government. We are neutral with respect to it. That means the power we draw is the power we send back to the grid, and hence we are zero with respect to that. There are many such buildings which are in world today operational. When I say many, I don't mean hundreds and thousands. There could be a handful of them today, but this is where the world is going. There are examples of these buildings in India also. My guess would be that these would be in somewhere in the range of about 10 to 20 such buildings in India at this point of time. The next is the net zero water buildings. These are the buildings where we are neutral with respect to the water which is coming to us from the municipal resources. That means we do not take anything from municipality. We are completely relying on what the rain gods provide to us. The focus of these buildings is on water conservation and storage. Such buildings are already being tried out. Currently, I may not be able to cite an example of which such building in India, but I can tell you that such buildings are being under design. They are currently under design. The third category of buildings are net zero waste building, where we are neutral with respect to the waste fill, landfills. Both pre-construction and post-construction waste is brought down to zero. And again, such facilities are currently under design, or very few of them are running also. One of them here in Delhi, which I had the privilege of visiting this place a few years back. The ultimate would be what we call a carbon neutral building. This is where we are in harmony completely. We are not adding anything to the carbon emissions. This would be the step which we'd achieve once we have done net zero energy, net zero water, net zero waste building. It will be a natural progression to move toward net zero carbon. Currently, we are little away from this these days, but that's where we are aiming for, and that's where we need to go if we need to harmonize with the mother nature. How do you go in defining what net zero energy buildings are? Generally, in case of India, renewable energy source would mean solar, because God has given us plenty of sun energy. Since we have plenty of sun energy, that's what we typically like to refer, even though our country is blessed with wind resources, with biomass, but generally we speak about solar. When you got solar energy, you can do generation when the sun is out, and that happens in the daytime. How do you run the building in the night time? There are two ways of doing that. One is that you store the electricity in batteries, but storage would mean it's expensive, and then it may not be environment friendly also. So what we do in such buildings is we generate excess power more than what we require for running the building in the daytime, send it to the electrical grid, the government grid, and in the night time draw the power back from there. The electrical meter that you got, which is monitoring it, the net power which goes out and the power which is imported from the grid, the net sum of it should reach zero, and that is why it is called net zero energy buildings. Mind it, the world over, the term is net zero energy buildings, not zero energy buildings. It's a standard term, and that's how the buildings are defined. How does one go around making it, constructing it? It's very simple. Go down to the fundamental. This is the famous energy triangle for a building. Look at the bottom of this pyramid. That's where the energy consumption of building stands. And if you look at this building, it's got a big base, the blue base that you see there. That means this building has a big power requirement. If I have to make a net zero energy building, I'll have to put the solar panels or any other form of renewable energy, which is going to be matching the consumption of the building defined by the blue base. But the same building is designed correctly in terms of using passive measures that we say harmonizing with the nature of right building form, size, orientation, right kind of glass, typically what an architect would do in a building design. We call it passive measure. The same building has now got a lower energy consumption base, what is defined by the green triangle. If the engineers do their job right, which is putting right air conditioners, which are very efficient, using lights which are efficient like LEDs, using good glazing, good elevators, good plumbing pumps, water supply pumps. If you use those efficient equipment, same building now has energy consumption which is defined by the yellow base. And look at it, the same building has a much lower energy consumption as against where we started with, which is the blue base. Now putting renewable energy source for meeting the power demand defined by this yellow base is much smaller. And that's what is the fundamental of a net zero energy building. Make the building efficient, very efficient, before you put the renewable energy source, and that's how you will be cost effective. I'm going to show you a video which I found on the website, on the YouTube, which is by ASHRAE. ASHRAE is the American Society of Air Conditioning Engineers, and it is a premier society which has been working towards achieving net zero energy buildings. They have a target 2022 to go net zero energy buildings. I'm going to run that video for you. Have a look at it, hear that, and you'll find exactly the same thing being talked about. All right, so that was the message of ASHRAE, how to go around designing net zero energy building. It was very similar to what I spoke about. Where do we start? Fundamental, go down to basics. And if you stick to basics, you can never go wrong. First, understand the climate for which you are designing. You cannot have a same building being built in a hot climate and the same thing being done in a city like Bangalore, which has got a much better, a different kind of climate. Secondly, learn from the history. If you look at India, every city has a history of its own. Every city has a different kind of buildings which were done. Ask any architecture student, he or she will tell you that the importance of that building design which was done historically by our ancestors, why it was designed that way. And if you look at those basics, follow that, you cannot go wrong. Then we got science like Vastu, Panchbhutas. It's all a science. Follow the science to extent possible. What sounds right, do that. Finally, you harmonize with nature. Use the building technologies that we have, air conditioning, electrical, whatever the technology that you use it to not to fight with the nature, but to harmonize with the nature. And that's what is the fundamental of high performance building design and towards what we say a net zero energy building design. I'm going to take you a couple of examples of net zero energy buildings which were done in India from the start. This is the first net zero energy building of the country, which was done in 2010-11. It's called Eco Commercial Building. It's in Noida, and it's in Greater Noida actually. And this was done by a chemical giant called Bayer. Bayer is a giant from Germany. They did it under their climate protection plan. The intent was to create a demonstrative building which will carry the message of what the future construction would be like. So 10 years back, this building was made. 2011, the building got completed. Small 10,000 square feet facility. When it finished, it became the greenest building in India at that point of time. I'll showcase to you the process that was followed to construct this building and how we got a net zero energy rating out of it, or the performance out of it. What you see at the table below, the first column shows you 3 parameters. The first one is annual energy consumption in kilowatt hours. The second is the cooling load. Third is the carbon emissions, the annual carbon emissions. The second column shows you the values for each one of it before the design was undertaken. And the last column will show you the improvement that happens in a step-by-step approach which was followed there. You can see here, just by doing the right orientation, whether it's north-south, east-west, what is the best orientation? So you use softwares to rotate the building every 45 degrees to find out which is the best orientation. And that orientation, once it was selected, saved us 1% in the annual energy bill. You will say, Arey, 1%, is this what all the trouble is about? Wait and watch what happens as we go along on a step-by-step approach. The second, what we did was put the roof insulation. We are a country which is hot. Most of the parts of our country are living in a hot climate. And for us, keeping the heat out matters because we got air conditioners running inside. This building saved 3% of its annual energy bill by going for roof insulation. Similarly, by wall insulation. How many of us actually put wall insulation in our buildings? Very few, but that's the way for future. If you're making a building in Middle East, in Europe, that's where wall insulations are compulsory. In India, it's going to become in coming days. Already the government is working on that idea. The codes are out. If you look at the ECBC code, that's what needs to be done. Look at the window assembly, double glazing unit, right kind of window wall ratio helps you save further electricity. Right kind of interior lighting. Daylight sensors, that means using the sensors to switch off artificial light when they're not required. If you get adequate daylight, why do I need to run the artificial light? Similarly, occupancy sensors, let's say places like toilets, pantries, mechanical rooms, where nobody goes there or goes once in a while, that's the place, if I'm able to switch off the artificial light when it's not needed, I'm saving energy. External lights, using good quality external lights, right energy efficient ones. Maximizing the daylighting. Here in this building is 90% of the areas were daylit. Looking at equipment like photocopiers, printers, computers, buying the ones which are most efficient. I remember the time when a personal computer used to consume about 250 watts of power. Today, that power consumption is down to less than half, and it should be our endeavor to pick up those equipment which are least power consuming, because they're running most time of the day, and you're saving energy by choosing the right ones. Similarly, the right kind of air conditioning systems. I'll take you to where we reached by all the step-by-step process, not going through all the details. We saved 60% power from where than as compared to where we started from. And at the end of the day, once we save that energy through energy efficient measures, we put 57 kilowatts of solar panels on the roof to get what we say a net zero energy performance. This is the images of the same building in 2010 when the construction was going on. You can look at the daylighting inside. And this is in 2011 when the building was finished. And again, look at the daylighting inside. These are some of the images from outside the building. And you would notice the tall overhang which is there on the roof, which you can see right here. That overhang is actually protecting the windows from a direct sun coming inside, but also simultaneously providing an additional area on the roof to put the solar panels. So 57 kilowatts of solar panels on the roof. And once the building started operating after 1 year in 2012, when the performance was noted, it was found that the total number of units which were generated by the solar panels was 72,000 units. Consumption was 64,000 units. We ended up generating excess of 8,000 units and sending it to the grid. That means our electrical grid became richer by 8,000 units. It was a net addition which was done to the grid, and the building performed as an energy positive building even beyond our expectations. Another building that came up thereafter was Ministry of Environment and Forest, again in Delhi. This is called Indira Paryavaran Bhavan. It's at Jorbagh in Delhi. Those of you who know this place. It's a 500,000 square feet, 500,000 square feet or 50,000 square meter building. Big building. And on top, the wings that you see there, those wings are nothing but housing the solar panels. The building is completely run by the solar panels which are on the roof. It generates 1 megawatt of power through the solar panels to meet its need. The third building in the series that came up was Shunne, which is a net zero energy house. Those of you who were there on Monday, the speaker there, she had presented the same house called Shunne. It is made out of 4 freight containers, old freight containers, where the doors and windows were cut out. Frame was put on the top for mounting the solar panels. On the left bottom is the conceptual image of that house as you see there, where the intent was to showcase what an ideal future living would be like. The house has rainwater harvesting, composting, green wall, kitchen garden, renewable energy, anything which makes the building sustainable. You see, this is the actual image of a completed house. And you can see in this how close it is to the performance that we had thought about. These are some of the images from inside, 100% daylit. On the left top, you will see the red color digital display. That digital display is nothing but the power which is being consumed is being logged, and the power which is being exported to the or being generated is also being logged. You can see the kind of daylighting inside. The furniture was all recycled, old furniture, which was refurbished and used out here. You can see that the earthen box, which is on the right, where my cursor is right now, this is the composting pit. This is the kitchen garden. And that's how the building was done. There's another one, which is a unique project here in Delhi, which is the first net zero energy park of India. This is developed by the Delhi Metro Rail Corporation, DMRC. It's again meets entire power requirement through the solar panels itself. And that's what makes it unique. I'm going to take you to one more case study before we start moving to the final images. This is a case study for a building which is done in Kolkata. It's a small building which is tall. The problem with the tall building is that you have very little area to put the solar panels. That means you can put it only on the roof. And that area being so small, you're not able to meet the power demand of the building itself. What we decided here was to wrap the building with solar panels. Now that's easier said than done. If you wrap your building with solar panels, you'll have no daylight coming in. There'll not be any view for the people. How do you make that efficient? A lot of these questions come into the mind. This is a perfect example of how those questions were handled by close working of an architect and an engineering company to solve the problems. What you see on the ground is the shadow being casted by the building year round. There's an area where there's no shadow being casted, that is represented by the green trapezoid. This is where it was decided to put some car park with solar panels on top of it to keep the car in shade and simultaneously generate power. All the 4 facades were studied with respect to the solar radiation. What you see here on the screen is the y-axis showing you time of the day and the x-axis showing you year. All these orange, red, yellow, this is the intensity of solar radiation depicted by the scale on the right. And you can see here we are trying to find out when is the solar radiation maximum, how it can be harnessed. Next, we are looking at the solar exposure. How many hours in the day do you get the sun on the facade? So such studies are being done for all the 4 facades and the roof for all months in a year, all days in the year when the sun is there. That helps us to determine the total renewable energy that can be generated. Finally, the floor plate. Looking at the floor plate, we are finding out how to make it daylit. If I do not have any solar panels, this is what the daylighting looks like. On the top, you see a very bright glare patch. That means the sun is coming unhindered inside. Nobody will be able to sit close to that window because the sun is very strong. Similarly, on the right, this is what we call a glare patch. Trying to solve that problem by putting the solar panels in an inclined manner like this, so that the people inside can get a view outside. They are also able to, there's no glare on them and the daylighting is not compromised. So this is the exercise being done in terms of arriving at right shading, right angle and right glass. So these iterations were done for that. And let me take you to the final one. And you can see here, this is the final floor plate. 99% of it is daylit. All the glare patches are gone. And look at the angle of the solar, which was determined, solar panels, in order to get the best of what we are looking for. Once that was done, the similar exercise was done for all the 4 facades and the roof. And finally, it was quantified in terms of how much power it is producing. What you see here, the building produces about 228 megawatt of power throughout the year. And if I divide that with the area of the building in square meters, I get a unit of 67 kilowatt hour, which is a unit of electricity per square meter or per year. This is defined as Energy Performance Index, EPI. If you look at, then the engineers started working on it, where the engineering of the building was done backwards. That means it was fine-tuned to an extent till the time the consumption was able to match what the generation was happening from the renewable energy. So it's a perfect example of a right design by the architect, cooperation by the client, and finally complemented by the design by the engineer. And at the end of it, you will notice that the consumption, which is 67 units of electricity per square meter per year, is matching the generation, which is 67.3 units of electricity per square meter per year. to achieve a status of net zero energy building. And you can see the conceptual images of what that buildings look like, how the solar panels have been installed there. Similar examples have also been done for getting a right kind of, let's say, basements. Now, whenever we talk of basements, the image come into our mind of a dark, dingy place where the mechanical ventilation is required. This is where the efforts to make it rightly lit, daylit, naturally ventilated has been made. This is a basement under the ground, completely underground. You can see here 4 large cutouts were created around the building which are bringing in the lighting here. Along with that light, you can notice from this, those of you who can see the movement on the screen, that's computational flow dynamics, to showcase to us the strength of the air currents that are being formed by the natural wind. More such cutouts at strategic locations helped us to get the same basement down to 85% daylit. I will not require any artificial light in the daytime. And look at the strength of the natural ventilation currents. I don't need any ducting. I don't need any fans, no power to run it. Everything is naturally ventilated. That's how the technology is being used to work with the nature, which is what I was trying to explain earlier. Last few slides, I'm going to show you of my own office where I operate from, where I'm sitting right now and talking to you. Normally, when we talk about green, the image that comes into our mind is of a big corporate, a large company, a rich company that is making their building green. Here, the attempt is that in our daily lives, you, me, all of us can convert our workplace, our homes into green buildings, into net zero energy buildings to get the benefit of what I have spoken about so far. This is an office in Noida. I invite all of you to please visit this. You're more than welcome, possibly after the COVID times are over. We've had many visits from the schools in past, and I'd like to extend the invite to all of you, IGBC Green chapters. Come and see that. This is an office which is 100% daylit. We don't switch on artificial light on the entire floor, not even in toilets, not even in pantries. In the daytime, you don't get to see a daylight. Look at the floor plate, 100% daylit, and you can see how the daylight is pouring in from all the sides. This office has got a platinum rating, which is the highest green rating given by the Indian Green Building Council for the buildings in terms of energy efficiency, in terms of environment friendly quotient of it. It has also got another platinum rating, what is called on a health and well-being scale. Health and well-being is all about the well-being of people inside, how happy the people are working here. And I can tell you, each one of them enjoys being in the office. As I said earlier, the office is 100% daylit, and very little artificial light that we need in the evening hours on the night time when sun energy is not there. It is achieved by a small amount of lighting which has been optimized, and I'm going to show you some images of that too. This is how the seating plans have been done. You can see on the screen the seating plans. They've been kept away from the window. The intent of keeping it away from the window is the direct sun does not hit the workplace. There is no glare which is coming on the computer screen, because moment there's glare, we'll end up making the blinds go down, and when the blinds go down, it'll become dark inside, and that's what we don't want to achieve. We don't want to do here at all. And as a result, you can see the daylighting in the various spaces, including the conference room. We also maintain a temperature of 27 degrees, 27 degrees on the thermostat with these fans being used. These are special fans which do not produce any sound, but they produce air movement. And at 27 degrees, when you got enhanced air movement, you feel like 23, 24 degrees. We got air cleaners, and look at the PM 2.5 levels. Now, those of you who follow the ambient air quality challenges which our countries have, cities in India have, you would know that Delhi is one of the most polluted cities in the world, where the PM 2.5 level crosses 500. In this office is less than 14, which is safe as per WHO standards. All equipment are energy efficient, and this is how what the typical office floor looks like. Air conditioner, fan, air conditioner, fan, and the entire ceiling is insulated. This is how the lights are planned. You can see a simulation model, computer simulation model, in which you can feel, you can clearly see the lights are falling on the workbench only. Outside the workbench, there is hardly any light going out, so that light is being completely utilized, and we are not over lighting the space, we are right lighting the space. Finally, this is how the spaces come out. Let me take you to, sorry, the image of that. Daylit space, it's a social gathering area where in the daytime, it's used as a meeting room, it is used for lunch, and then also used for our functions that we do there. The electricity bill of this office for 10,000 square feet office is yet to cross 70,000 rupees a month, which makes it unique and energy efficient. Now we are looking at a net zero energy rating by putting the solar panels on the roof. And that's how simple it is to make a net zero energy building or your office or workplace net zero energy. There are rating systems now available from Indian Green Building Council, IGBC. There is a rating system called Net Zero Energy Building Rating System, where you have to provide 12 months data, 1 year data, and prove that whatever the consumption took place was met through the renewable energy source. Once you demonstrate that, you are eligible for a net zero energy building rating. The focus of the rating system is exactly what I told you. Make the building energy efficient before you put the renewable energy on top. These are some of the buildings that have got certified by the Indian Green Building Council in the last 1.5 years. Now you would say only few of them, 5, 6 of them. Again, net zero energy buildings are the ultimate in terms of sustainability. Not everyone can achieve the status. The intent is that we move to an era where all our buildings are net zero energy, but till that point of time, today, there are only a handful of them, as I said earlier. In India, there are hardly any, between 10 to 20 buildings we have. And these are 5 of them which have been rated by the IGBC. IGBC own headquarters in Hyderabad, which is a platinum rated net zero energy headquarter building, has got 138 kilowatt of solar panels on roof, producing electricity, meeting 100% of its demand through the solar panels itself. This is an office building in Mumbai. This is for a bank, ICICI in Jodhpur, which is a place where it's ideal for producing renewable energy. This is Capgemini in Bangalore. This is for a warehouse in Navi Mumbai. Look at the different types of building which are going net zero energy. Today, there are very good examples of the net zero energy buildings in India, which are trendsetters. We have, those of you stay in Delhi, Nagpur, and other places, you would note that government has put solar panels on roof of every metro station. Most of our metro stations are now going with renewable energy. Cochin Airport is a net zero energy airport. Entire roof is covered, of the terminal building is covered with a solar panel, meeting its demand through the renewable energy that is generated there. If you look at the universities coming up, IIT Jodhpur, I heard about Nalanda universities. All of these are aiming for a net zero energy performance, where the intent is that the entire energy is met through a renewable energy source. These are large projects, and you can extend the same thing to your own house, your own office, because it is not tough to achieve that status. It's all about doing the right sizing, right design, right thought process, and right operation. A building which is well designed and not operated correctly can still have a problem in terms of achieving a net zero energy status. That's why you not only have to design it right, you have to operate it right, carefully, keeping in mind that all the wasteful energy is taken out of the system and we are only using the energy what is required. And that's what requires a mindset change in how we think and how we operate our buildings today. Net zero energy buildings are the way forward. Most of the governments across the world have set their target very clearly on where the net zero energy buildings would go. Germany is today meeting 70% plus of its power demand through renewable sources. A lot of European countries have a clear target that between 2022 to 2030, their buildings, all new constructions would be net zero energy construction. Government of India is also not far behind. Bodies like Ministry of Environment and Forest, Bureau of Energy Efficiency, MNRE are talking about the same concept, and you will be hearing more and more about it as you start working professional in your field. All of you are students, most of you would be students, and that's why I said once you come out and start operating or start working as professionals in the next few years, this is what you will see as a real challenge being put to you, and the building industry would be moving in this direction. I'd just like to end by saying, what is the way forward for India? Definitely we want to move away from this kind of scenario that we have seen. This is a familiar picture anywhere in India you go. Our infrastructures are overloaded. We are relying on a government infrastructure which was laid many years back, overdrawing from it, which can become a cause for fire, or which is a cause for fire and not even looks right to see. This is where we want to go in future, where we are using our power lines for a better purpose. Once we are meeting a demand through a renewable energy source, I definitely don't need these. I can use them for drying clothes also. Thank you very much. I hope you carry the message back to where you come from, and build responsibly, live responsibly. Thank you so much.
Thank you, Ashish. That was honestly a wonderful session with a lot of case studies. The highlight, I think there were a few points which I want to talk about. It was about the mindset, which is about the right design and how do we operate it. The entire flow of the presentation was brilliant with the pale blue dot, where you spoke about how we need to live in harmony with nature, about the lovely case studies that you showed. And I think the best thing was your office, which is truly working towards a sustainable lifestyle. And I think it's when you lead by example is one of the best way to learn it and do it yourself. So thank you so much, Ashish, for the wonderful presentation. We'll definitely, there are a few questions in the chat box, which I would love to take one by one. So I request everyone to put them down. But moving on to the first question, we would go. So how can we inculcate such net zero concepts in residential sector? And what about the cost estimates for the same? So I think cost is a very big factor that comes across to most people. So what are your, so could you answer that please?
Sure. Keda, I'm glad that whoever has asked that question, and you rightly said that the cost is the major consideration. But if you look at whatever the case studies I showed you, whether it's my office, whether it's a house, whether it's an office building, it doesn't matter. At the end of the day, we are designing the way it should have been designed. Only way when, okay, the cost of a net zero energy building is only adding solar panels or renewable energy source to it. There's nothing extra that I'm spending. Everything else is just a design, which any case what your office should be like, what your home should be like. So my answer to that would be simple. You are spending nothing extra except the renewable energy source that you need to put on. And today, if you look at the solar panels, they are being put on residential societies, they are put on office buildings. You go around because the solar panels are so cheap now. I remember, in fact, 10 years back, whatever the solar panel price used to be, today's 25% of that price, 1/4 of that price. So they're quite affordable. The key is that your building should be first made energy efficient. which you should do it in any case, whether it's a net zero energy building or a regular building. And once you have made it energy efficient, that's when you should put the solar panels. You can do it for residential, you can do it for house, you can do it for office, you can do it for railway station, you can do it for airport, you can do it for anything. As I said that in few years from now, all buildings will have to achieve the status. Today is voluntary. We are trying it out. Tomorrow it will be mandatory.
Thank you, sir. I think what you clearly mentioned is about the investment that you make in the design phase. That is what is going to help build these sustainable buildings. This is a question from my end. What about the maintenance costs that are needed when you build such energy efficient building? Because there is one-time investment. But I'm sure when you spoke about there's right design and right operation. So what are these maintenance costs that are required for this? When you build an energy efficient or a net zero building. Can you shed some light on that, sir, please?
So again, as I said earlier, that I'm doing nothing extra in a net zero energy building. Only thing I'm putting extra is the solar panels. So your maintenance cost is exactly the same what it was earlier. Only thing you need to maintain solar panels or windmills or whatever you're putting. Generally, it's solar in our country. That's what is more used. And what do you need to maintain a solar panel? Nothing. Just clean the surface regularly using a cloth or washing it so that the efficiency of the panel stays high. That's all what the solar panel requires from you. So you're really not spending extra. Okay, there are few maintenance elements, but it's not that expensive that we need to worry about because the savings are running in much more, far more there.
Right. Thank you. Another nice question, I think, from Varna Vishakar is, what are the specific considerations for carbon emissions while implementing net zero energy buildings? So are there any specific considerations that we need to take about?
So at this point of time, if you are cutting down on the energy consumption itself, that energy consumption cut, the kilowatt hour or the whatever the units of electricity are, you can actually convert them on equivalent of the carbon emission. So net zero energy buildings are reducing its carbon emissions by primarily cutting down on energy consumption. Because when you have lesser energy demand in the building, less energy consumption in the building, your generation also is lesser. That means what is happening at the power plant is also reduced. So that could be converted into equivalent of carbon emission. If you remember the first building example that I showed you, which was of Bayer, the first net zero energy building of India, I had shown the carbon emission equivalent of that. So we did save in that building by reducing our power demand by half. The reduction in the carbon emission was close to about 40% in that
building. Right. Thank you, sir. Moving, I think there are two questions that we can take so that we stick to the time. I think this was more about it's about Oshin. You spoke about having a net zero building, but even during the time of construction, a lot of energy is used, right? So it's, you're saying that there is no energy requirement, but what about that part? How can you reduce that usage is a question that was placed there.
Excellent question from Oshin. Excellent question. So I have been trying to keep the whole talk to a very fundamental level, but yes, you can expand that part of discussion. Now, net zero energy buildings, you need to set a boundary under which you're evaluating. That boundary could be once the building is finished, completed, and it's operational. The boundary is the amount of power I'm consuming while operating the building. That's one boundary. I can expand the boundary to say, include the construction time also. So the amount of energy that was consumed in construction, I need to offset that too. So I can also go to the losses that are taking place while the transmission is happening from the powerhouse to my building. I can expand the boundary to go there also. So it depends on what boundary you set. That's a higher, I would say that's That's something you can keep doing at your end to make it, to reduce the carbon footprint of that building. Typically, for simplicity's sake, we always refer to a building which is in operation, and we leave the other parts out, because 90% of the energy, or more than 90% energy in the lifetime of a building, is consumed in operation, or 95, 98% of it. Is only 1 to 2% is what we do in construction. So we are looking at the bigger piece, bigger pie. But yes, in a truly sustainable world, which is where we will be in near future, we will expand the boundaries to include other things. Excellent question from you.
Yeah, I think that was a very nice. It's about knowing your boundary and knowing how much energy would be needed. It was a really nice question. I think we would conclude with today's session, and I'm sure anyone who wants to ask questions can email Sir as well, because we have more 3 minutes left. So I would move on to the closing remarks and take it forward from there. Yeah. So, yeah. So thank you again for having being with us at the Prem Jain Memorial Trust for this lovely session. The other questions I think are can be explained very well, and I request if you would want to take them, we can take them. Just sticking to the time of 3 more minutes. So.
I guess there's nothing else, so we can close the session.
Yes.
Thank you very much, everybody. Thank you. Thanks for being here, Ashish. Thank you, Siddharth. Thank you to Keith, all the students. Ankita, Sandeep Narang, everybody here. Thank you very much. Thanks. It was a wonderful session, Ashish, as usual. You always something new that I learned from your presentations. Thanks very much.
Thank you so much. It was indeed
Thank
wonderful.
you, Payal. Thank you, Ankita.
Thank you so much, sir.
Thank you, Siddharth. Take care.